Hello friends, welcome to VFix India YouTube channel. In this video, I want to give you information about our recently launched e-classes for mastering LCD panel repairing solutions. Basically, these e-classes are designed for our technician friends who are involved in LCD and LED sets repairing. In these e-classes, we will include the recent technologies LCD panels fault finding process and repairing solutions. That will help our technician friends to enhance the knowledge in the field of LCD panel repairing process. Basically, there are total 18 e-classes, each of 90 minutes. We have divided all the e-classes in 3 segments. From e-class 1 to 8, we focused on T-Con board and scalar PCB repairing and fault finding solutions. And e-class 9 to 11 is focused on the COF IC faults and the solutions of the COF IC replacement process. In e-class 12 to 15, we have focused on panel glass inside circuit problems like jumping pictures, scale line problem, horizontal line problem, etc. We have given all type of solutions with practicals live in the e-class. In e-class 16, we have focused on the replacement of compatible panel with any broken panel and not repairable LCD panel. And in e-classes 17 and 18, we have taken hands-on practical of live repairing for the typical faults like AVDD is not generating, AVDD shorting, VGH or VGL missing, gamma signals are missing, or CKV line fault. And we have taken some practical of bonding solutions in this hands-on practicals. Now, I will show you class 1 to 8 in detail so you can understand how we are going to do knowledge transfer in our e-class. I will show you some parts of our e-classes itself so you will understand how we will do the knowledge transfer in our e-class. We start with e-class 1 to 8. In that e-class 1 to 8, we start with the motherboard power sequence and the important test points of motherboard. After that, how this panel supply PVDD is created from the panel on signal sent by the motherboard controller chip. Basically, as you can see in this practical on the screen, there are 2 MOSFETs in cascading and this panel on signal on motherboard controller switch on the first MOSFET and this MOSFET switch on the second one, and after that this PVDD is created. So any set with no PVDD you can easily repair fault of no panel supply. Then come to the LVDS connector. Basically, there are 2 types of LVDS connector with 51 pins and 30 pins. In this LVDS connector pins, there is panel supply, ground pins and LVDS data pins. There are different types of LVDS data pairs like 5 pairs signals, 10 pairs signals and 12 pairs signals. And in these pairs, the RGB data, horizontal sinks and vertical sinks are coming as per the JIDA format, as per the VISA format, or as per the 10-bit panel format, or as per 8-bit panel format. So we will explain everything in detail, what is coming inside this LVDS data pairs. Then some control signals like LVDS mapping, panel ID mapping, STA, SCL pin, write protect pin, and the bit select pin of 8-bit and 10-bit panels. So every control signals will be explained, how it is coming from the motherboard and what is the function and how to alter these signals for the compatible panel replacement process. After LVDS connector, we will start with the DC to DC IC section. In the DC to DC IC section, first step is creation of 3.3 volts from the panel supply. This 3.3 volts is basically a supply voltage for the T-Con IC and EPROM of the T-Con board. Now this 3.3 volts is created using buck circuit. In this buck circuit, DC to DC IC supplies a switching pulse and a combination of inductor coil and diode creates 3.3 volts using this buck circuit. We will give you the complete practical explanation of working of buck circuit. After creation of this 3.3 volts, the 1.2 volts for the core supply and 1.8 volts for memory supply are also generated from this 3.3 volts. Now the next step is AVDD generation. For the AVDD, there is boost circuit that generates 15 to 16 volts from the supply of 12 volts. For the same, there is a combination of induction coil and diode, and a switching pulse from the DC to DC IC is supplied to this boost circuit. And how this boost circuit IC is happening or working? What is the shape of boosting pulse? Those all we will show you in our practicals in the E-class. And also, we will provide you the process of finding the fault if there is no AVDD and if AVDD shorting is there. After AVDD generation, the next step is VGH and VGL creation. In this VGH and VGL generation, the DC to DC IC sends positive drive pulses and negative drive pulses to VGH and VGL departments through a flying capacitors. And these flying capacitors are connected to dual diodes that are known as positive drive pumps and negative drive pump respectively. Now any faults related to the VGH and VGL we will discuss in this section, and I will show you practicals on DSO, how these pulses are coming to this DC to DC IC. And also we will explain how to check some test points using multimeter as well. After finishing this 3.3 volts, AVDD, VGH and VGL sections, we will discuss about the feedback circuit. Each of these voltage circuit is the feedback to the DC to DC IC. If there is any problem in this feedback circuit, then there is a problem in the voltage output. So we will explain about the fault related to the feedback circuit as well. We will explain this DC to DC IC circuit, all departments using these schematic diagrams, and also we will show you practical using DSO and multimeter voltages testing points. Now next section is T-Con controller IC. In this T-Con controller IC, the basic function is LVDS data to RSDS data, and this RSDS data is supplied to the source COF or XCOF, and that goes inside the panel glass as a triggering signal to the sub-pixel lines of red, green and blue inside the panel glass. Another function of this T-Con controller IC is to generate timing control signals like STV, CPV and OE. You can see on the screen, we are showing you how we are observing this STV, CPV and OE pulses using DSO. In the panel with the side gate COF, this STV, CPV, OE, VGH and VGL etc. signals are going to side gate COF using direct tracks. And in type of panel with no side gate, there is another IC called as level shifter IC or scan drive IC. The function of this level shifter IC or scan drive IC is to generate the amplification of the VGH and VGL level with the reference of timing control signals like STV, CPV and OE. These analog amplified signals are known as CKV pulses. These CKV pulses are in the pair like CKV1, CKV-B1, CKV2, CKV-B2 and CKV3, CKV-B3. And in some cases, it is CKV4, CKV-B4 also. These are also known as HC pulses or clock pulses. Now these CKV signals are going inside the panel glass gate circuit to the direct tracks of both side last COF. In some set of LCD panel, there is another signal coming out of T-Con controller IC that is known as YV1C. From this YV1C signal, the scan drive IC or level shifter IC creates the signals known as LC1 and LC2, which is a switching signal between the VGH and VGL level. We will show the fault related to LC1 and LC2 signals. Next is gamma section. In the gamma section, there are two types of gamma IC. One is programmable gamma IC and another one is non-programmable gamma IC. In the set with non-programmable gamma IC called V-reference, in short term is VREF, is created from the AVDD. And from this VREF, using voltage divider networks of resistors, generates gamma signals from the range of 14 volts to 0.4 volts. And these gamma signals are supplied to gamma IC and Gamma IC work as buffer IC. And this output of Gamma IC is going to the source COF as gamma signals. Also from AVDD, VCOM signal is generated and VCOM is also supplied to the source COF as well as the gate circuit of the both of LCD panel. Now in case of programmable Gamma IC, the AVDD is supplied to the programmable Gamma IC. And this programmable Gamma IC generates gamma signals directly. There is no voltage divider circuit in programmable Gamma IC. But if you are replacing the programmable Gamma IC or a programmable DC to DC IC, you have to flash a new IC. That means you have to reprogram the new Gamma IC or programmable DC to DC IC using an EEPROM programmer. We will show live hands-on practical for reprogramming Gamma IC and DC to DC IC in our E-class number 7. After finishing this section of DC to DC IC, TCON IC, Gamma IC and Scan Drive IC, we will show you different types of most running TCON boards as well as the scalar PCB. And we will discuss about the most running DC to DC IC, Gamma IC, TCON controller IC, level shifter IC, and we will show you the practicals on this most running models ICs. So the first section of E-class 1 to 8 has been finished. Now we will see class 9 to 11, that is focused on the COF IC. First we will start with the fault related to COF IC, how to identify that this fault is related to the COF IC only, and also how to confirm that we will replace the COF and fault will be 100% solved. So we will give you some practical tips and tricks for pre-observations before the replacement of COF using ACF bonding machine. Also, we will show you how to remove the COF by using COF removing station. You can see in this video, we removing the COF glass side and PCB side very easily using this COF removing station. After removing the COF, you need to clean the tracks of PCB side and the glass side bonding area. We have developed the special method to clean the glass tracks using nano sponge and IP chemical without the ACF removing chemical that damaged the glass tracks in some LCD panels. We are using the moving microscope set for live view of glass tracks during the cleaning of glass tracks process. You can see on the screen, we are using microscope setup for live glass tracks cleaning process very easily and very handy method for the fast and safe cleaning of glass side tracks. Next is the COF preparation. First to cut the COF from the COF roll using COF cutter. After cutting the COF, we need to apply the ACF tape on the COF. There are two possibilities. One is to apply ACF tape on COF and another one is you can apply ACF tape on glass side directly. Both of them we will explain you using practicals. Both have some advantages and disadvantages. After ACF tape apply, we will show you how to do a perfect ACF bonding using the ACF bonding machine. To get a perfect ACF bonding, you should have a proper pressure and proper temperature according to the type of COF. That means if you have a normal COF around 45 to 50 mm width, you should use a standard profile. And if you are doing a bonding of big COF of around 65 mm width, you need to change the pressure and temperature of the bonding machine. For the same, we have developed the different types of COF bonding profiles in our bonding machine. For big COF bonding, you need to select big COF profile from the profile selection button. Similarly, if you are bonding with 4K panel, in the 4K panel COF, the COF tracks are very thin and dense and very near to each other. You have to select the profile most suitable for the 4K panels, and in some cases, you are bonding with old COF, then you have to select most suitable profile for the old COF bonding. So using different profiles for the different types of COFs gives you 100% accurate and most strengthful bonding. And that bonding remains long lasting, or there are no possibilities or no chance lines coming back on the LCD panel after replacement of the COF. In the ACF bonding process, we will also explain you how to maintain ACF bonding machines, like how to do the head cleaning regularly and also some different parts routine maintenance process. We will explain you in some practicals, and also after making the bonding and how to secure the bonding for long lasting, and how to do the burning test of LCD panel, that we will explain in class number 9 to 11. After finishing the bonding section, we will start class 12 to 15 about LCD panel inside fault and the working function of LCD panel inside circuit. First, we will explain how the LCD panel works, how the colors are created in LCD panel, and the basic information about the LCD panel working system. We have developed a moving microscope to observe the panels inside circuit. And now you can see on the screen and find the fault in the panels class inside circuit. You can see on the screen by using this moving microscope in the XY direction. We don't need to move panel, we move the microscope itself. And now you can see the practical of observing the side gate tracks from the side gate COF. These tracks are coming out of side gate and going to the source COF tracks. You can see the practical on your screen now. The same way here, you can see CKV lines observations. These CKV lines are going to both the sides of LCD panel, and from both sides, these CKV lines are going to SR block circuit. And from this SR block circuit, output is converted in the gate lines that is known as Y line or horizontal line. So any fault related to the CKV lines or CKV line leakage, you can observe using this moving microscope. You don't need to move panel. Also, you can observe bonding area after the bonding process, or also you can observe the data lines out of the source and going inside the panel to the RGB subpixel vertical lines. You can see on the screen that we are observing the RGB subpixel data lines using this moving microscope. In this way, this microscope is very useful for observing all types of LCD panel glass inside circuit. And the main benefit of the observation is that you will find fault, and also you can do glass track cleaning during the ACF bonding process live by viewing this moving microscope. And there is no possibility of damage during glass side cleaning like this. After panel glass circuit inside observation, and we have some idea about the cause of fault, we can do some alteration in CKV lines for the faults like jumping picture or Y lines on the LCD panel. For the same, we have developed the special method to cut the CKV lines and step-by-step methods, so you need to cut very few CKV lines, you don't need to cut all CKV lines. So the picture quality we try to maintain as much as better after cutting the CKV lines. And in some case, if you are finding the scanning line problem in LCD panel, we will have a special method to remove the scanning line using some alteration in scanning line tracks. That all we have included in E-class number 12 to 15. In E-class 16, we have taken practicals on the changing LCD panel compatible one. We will show how to do LVDS mapping, meaning switching between the ZADA mapping and VESA mapping. Also, in the Sony TV set, we will show how to panel ID matching with the new panel installed using SCL and SDA connections on external EEPROM to the new panel. Also, we will show how to use the bit select signal to the matching of 8-bit and 10-bit panel types. And also, we will see how to do mirror solution, that means the vertical picture mirroring solution using some alteration in TCON and scalar PCB circuits. In E-class 17 and 18, we are taking hands-on practicals of live repairing most of typical faults like no AVDD, no 3.3 volt creation, AVDD shorting problem, gamma IC not giving output, level shifter IC, CKV signals are not coming out. Or faults related to the CKV leakage, that means the jumping picture, and some faults related to the bonding of different types of COF. We will take as live practical repairing, and we will show these type of practicals in E-class number 17 and 18. Friends, As you have seen that our E-classes are full of practicals, and after going through these E-classes gains the new faults finding process methods and the working of LCD panel circuit. You will have your own method to find the faults and repair the faults. I am sure that you will be able to handle the difficult level of LCD panel fault as well, and your repairing efficiency of LCD panel will increase very much. These E-classes from 1 to 18, we call these E-classes as Pro version. We have another advanced version that we call as the Ultimate version. In the Ultimate version, there are 3 different additional features that are given. The first feature is panel glass circuit understanding and fault finding process at deep level. Normally, the person who is using the laser machine for LCD repairing or the person who want to buy a laser machine for LCD panel repairing process should go with the Ultimate version E-class. In the Ultimate version, we will give hands-on practicals on LCD panel glass inside circuit fault repairing using the laser machine's operations like CKV cutting, leakage in CKV lines, scanning line solution, jumping pictures that are not solved after the CKV lines cutting, and also Y lines, that means horizontal line solution repairing using laser machine. Another feature of Ultimate version of our E-class is that we assign one technical person to whom you can make video call, and he will assist you during any of fault you are repairing. And if you have some problem in troubleshooting of that particular case, so you can make video call to our technical assistant, and our assistant will guide you how to do the troubleshooting and solution of fault step by step using the video call process. The third feature of Ultimate version is the support for the spare part resources. In this, we will share our worldwide contacts which we have gathered with our years of experience. For different types of spare parts like motherboard, scalar PCB, T-Con board, COF IC, backlight, and even new panels, which we will share with you, and from those resources, you will get genuine spare part in very less time. So overall, your repairing speed and response to a customer will increase with support of our spare parts resources sharing. So friends, the 3 main features of Ultimate version E-classes are training of LCD panel repairing with laser machine, online technical assistant with video calling support, and the last is the spare parts resources sharing. Friends, I hope that you will join our Pro version or Ultimate version E-classes, and you will enhance your knowledge, and eventually you will increase your repairing efficiency in your service center. Friends, thank you very much for watching the video. For any queries or doubts you may have about the technical knowledge transfer process, you can join our demo E-class that is free of cost. And also you can subscribe to our YouTube channel for getting updates. I hope to see you soon in our E-classes. Thank you very much and have a great day.